Hello everyone, thank you very much for joining me again. This is lesson 15 of the Spring Security Fundamentals playlist, and today we continue our discussion on the resource server with Opaque tokens. Thank you very much for being here with me. For those of you who watch the event live, don't forget that you have a live chat, and of course if you are not watching the event live, don't forget that you can leave your questions and comments in the comment section, and of course you can anytime, and I do advise you and suggest you anytime to check me out on Twitter and LinkedIn. You will see me posting a lot there as well. With that being said, I don't want to spend a lot of your time today. I want to deep dive in the subject. This is anyway the second part where we discuss the resource server, which means that I expect that you already followed the previous lesson at least. And of course, I do expect that you have knowledge from everything that we have already discussed here throughout the past 14 lessons. We will today go into discussing Opaque tokens. By the way, someone told me that I wasn't pronouncing it right, and I wasn't indeed. I was pronouncing it more like French opaque tokens, but it's actually opaque, meaning non-transparent. Okay, so we discussed up to this point, we discussed non-opaque tokens. The JVT tokens are an example of non-opaque tokens because they contain data. You can see the data in them. We have discussed, we have proved that, today we see what happens when you have an opaque tokens. I will start with reminding you how things work in terms of client, authorization server, and resource server, and then we will start a new project and we will create a new resource server that works with opaque tokens. So that's the plan for today. Hi everyone, thank you very much again for joining. I see a lot of you already here. I say hi as well. We have the classic diagram. You know, I just changed the icon of the client because a lot of people seem to be confused by the fact that I have always used the browser here. I meant, and I always said, that a client is a client application. Doesn't matter what kind of application that is. So it might be a mobile app, it might be a browser, meaning it might be a React or Angular application running in a browser. It can even be a desktop application, and sometimes you even have a different service, backend service, acting as a client for another service. So that can happen. Okay, when I say client is just a concept of whatever application needs to get authorized against another one just to use some of its resources. So you remember what happens is that using a specific grant type, usually the authorization code grant type, the client gets a token. So the client gets a token. Let's make it like this to be clear that the request ends up with a token being sent by the authorization server to the client. So this is the access token. Okay, and then this access token is what the client uses to prove to its backend that indeed it has been authorized, and then the backend will give them privileges. Now we have seen that when we have non-opaque tokens like JWT tokens, it's very easy for the backend to figure out if a token is valid or not, and the data comes inside the token because that's why it's called non-opaque, because it's transparent, it contains data. So the easiness of using JWT tokens is what made JWT being very very often used today in systems, and that's what we discussed in the previous lesson. But now I want you to know that non-opaque tokens are not the only option you have. JWT tokens are a kind of a tokens, but OAuth2 specification doesn't imply you necessarily need to only use JWTs. The alternative to JWTs are the opaque tokens. So the opaque tokens have this problem of not containing data inside. They are neither signed nor they contain data inside. So in that case, of course, the question is, when the access token reaches the backend, which is also called the resource server in OAuth2 terminology, how does the resource server know which are the roles, actually what is the user in the first place, what is the client, which are the authorities? How can the resource server, the backend, apply authorization rules only with an opaque token? And the answer is introspection. Introspection means that the resource server will call an endpoint called the introspection endpoint on the authorization server, will send the token and will get a response back from the authorization server. And of course, if the authorization server doesn't know the token, it means the token is not valid. If it knows the token, it will return a response with all the details the resource server needs. So that's as easy as that. And that's what we want to implement today. In one of the past lessons, I have already showed you how to do that at the authorization server side. Now we will implement the resource server side of the backend. So let's see. What I have here is the authorization server that we have already implemented, the way it was implemented in lesson 13. And I will change this one, and I will make it for our client, for the client that we have registered at that time. I will make it provide an opaque token for access instead of a JWT token. Once we prove that this works at the authorization server side, we will create a new project and we will implement the resource server that can use the opaque token for authorization. So that's basically it. Now, for the authorization server point of view, things are very simple. Now, remember that for this example, we had most of the data of our client in the database, because at that time the subject of the lesson was how to implement the contracts for storing the client and the user details, and I showed you how you can store them in the database, but I didn't store all the information. Normally, you know that in a real world application, you will need a few tables there that will store all the details of the client. And I hope that's something that has been clearly understood a few weeks ago when we discussed that. Now, I will not spend a lot of time putting everything in the database, because you already know how to do that. I will show you where is set up the information needed for the tokens. And to change the token from the default, which is non-opaque, into an opaque token, you will use the token settings. In general, anything that's related to the tokens is done through the token settings object that you set at the client level. And one of the things that we did the last time is actually we set up a very large time to live for the access token. And I told you that's something you should only do in real world. We should only do in examples, and you should never have such a large time in real world applications, of course. Now, of course, we can define the format. So we can use the so-called reference format, which actually means opaque. Okay, this is an opaque, non-transparent token. And if I'm running this now, I should be able to, one, get a token that is opaque, secondly, use the introspection endpoint, and prove that the Opaque token really works. So let me actually start this application and demonstrate first the way the authorization server works, and until this is compiling and starting, I can even now check out what your questions are by now already. Okay, a lot of appreciations. Thank you very much for your appreciations, guys. I hope you like and you enjoy my content. So, is client credential authentication method safe enough for server-to-server communication without human? Actually, it is the only one, so it is safe enough. And of course, in case it's a server-to-server communication, you anyway can't use the authorization code grant type, because that one implies you have a user. So in this case, you really don't have a user because it's server-to-server. So yes, the client credentials grant type is actually made for exactly that purpose. When you have an application to application, usually backend to backend need of authentication. And one of the examples I have given you is when you have some kind of a third-party software, such as monitoring software like Datadog, for example, or an orchestrator such as Kubernetes, a service mesh such as Istio, and stuff like that. They are applications at the server-side level. They sometimes need to call the application they support, and if you want to make that in an authenticated way, one of your choices could be the client credentials grant type. If you want to do it through an OAuth2 framework specification, of course, there are also other possibilities, like the simplest one most likely being HTTP basic. You can even implement HTTP basic anywhere, but it really depends on what you want to do. So if you want to do it through an OAuth2 reference way, then you do it with client credentials. What is Fast Node Express API or Spring Java based? I don't understand this question, sorry. Maybe you can give me more clues on what you mean. Authorization server will have database, right? Yes, we'll have. So sorry if the diagram is unclear, because one of them has database, the other one doesn't have a database. They are just some icons I have fastly found on the internet. But yes, both of them may have databases. I mean, your backend may have or may not have a database, depending what it does. The authorization server may have or not a database, depending on how it stores the users and the clients. I hope that is clear now. And can you set the JWK endpoint as properties file entry? Yes, you can do. Actually, whatever I'm setting in the resource server last time, I prefer to put them in the code to make the things easier. But one of the points that they should never be directly in code. Remember, I think I've already told you that. Never directly in code. You can extract them with the at value annotation and have them from a properties file. That's very important. Secondly, and that's related to any detail that can change from an environment to an environment. So whenever you have properties that change from one environment to the other, they should never be hard-coded in the code. The Spring Boot itself provides also a property that comes out of the box, but I didn't want to directly use that one because I want you to, from this series, to understand how things work inside the framework. If I just have added a property there, it is most likely that you have never understood what the heck, how is that I'm putting a property there and it's working. So I want you to understand at least, I'm not going very deep, but at least the shallow part of the framework. And that's why I didn't simply use the direct property from Spring Boot. Okay, I'm now taking back my application, and I'm going to, first of all, I need Postman. Here it is. Secondly, I will need a browser. Here it is. And thirdly, somewhere I have already copied for you here the URLs, so let me do something like this. Okay, so I don't want to write them again by hand. Going in the browser, I'm putting it here. I'm authenticating using my user in the database. If I correctly remember, it was Bill and the password was 12345. And then of course the page doesn't exist, but I get the code. because I'm just simulating my client here. So normally the client would have this page and will use this code as I'm doing now through Postman to get the access token. So now I'm going in Postman, and remember, and that was one of the things that looked like it complicated your lives, guys. The token endpoint is a post endpoint, because I got a lot of messages where people were asking me why it doesn't work, and for almost all of them the problem was that they were using get instead of post. So let me use the authorization code grant type here and get the response. You see the response here is the access token. ID token is kind of irrelevant in this situation, because it's unlikely that you would use an ID token with an opaque access token, since with an opaque access token you usually get the details from the introspection call. In my case it remained here because I think the way I configured my authorization server a few weeks ago, it was with OpenID Connect. So now what I'm doing, you can see this is just a string. You can at least see that it's different than a JWT. JWT is, it looks like this. It's a lot larger. It has 3 parts separated by points: the header, the body, and the signature. This is just a normal string, okay? And the point is, it really doesn't contain any data anyhow. It's not like an encoded somehow string. Like in the case of a JWT, we know that these are base 64 encodings, but in case of the opaque token, this doesn't contain data. The reason it's called opaque is because it's not transparent, meaning you can't see data inside. To get the details, you necessarily mandatory need to call the introspection endpoint. So it's the only way in which you can get the details about an opaque token. Now, if you go on the OpenID configuration documentation endpoint, the endpoint that provides you with everything related to your authorization server, you will see multiple things, including the authorization endpoint that we have already used, the token endpoint, the keys endpoint, which is not really essential for us now, the revocation endpoint. Some people asked me if you can revoke JWT tokens or access tokens in general, and yes, you can revoke them using the revoke token. Now we are interested in the introspection one. So here's the introspection one. So introspection endpoint is also called via post. You can see this is exactly the one I used. Okay, is the one here. And then it uses the token request parameter with exactly the token value. So what I'm going to do is I'm going to, oh, sorry for that, not this one, but this one. So let me copy it. Here, and the authorization by default, it uses basic authentication with the client credentials, which for me they are client and secret. So when I'm sending the request here now, the response will contain all the details needed. The implementation of the introspection endpoint, what you see here is the way it's implemented out of the box by the authorization server framework. You can customize it if you want, but of course, yeah, you can, or you might not want to customize it if you don't need that. But if you need, you can customize it at the authorization server side level. So with these regards, we have proved that the opaque token works, the introspection endpoint works, and we can get the details. Let's now prove how we can implement the resource server. So I'm going to create a new project. I'm going to call it SSC15E1. I'm still using the latest long-term supported Java 17, the latest Spring Boot 3.02, and I do need, because being a backend of a web application, it should have the web dependency. Being I'm discussing authorization is Spring Security definitely, and because I want to make it a resource server, then I also will add separately the OAuth2 resource server dependency. And now I'm starting my new application, and I will wait for everything to get indexed while I will still read your new comments and questions. What to use at the backend? Node APIs are faster compared to Fast API by Python. Here, this is not a Python course, guys. So sorry for that. I'm not a Python expert. I cannot answer your question. So if you have Java related questions and usually specific to what we discuss, I would be very happy to answer them. It could be nice if we can extend this topic to use authorization server with cloud gateway. Let's let that for another lesson, because you see it. First of all, let's take it step by step and make sure that you understand how to create a resource server, and we go to that afterwards. The access token expires every time the authorization server restarts. Is there something I'm doing wrong? The access token, if it's a JWT, it expires. It doesn't expire. What happens to you is that you use keys that are in memory, which is not what happens in a real world situation. So you can see here in our configuration, the way we configure the keys are in memory. We create a bin, and here is where we generate the keys. What happens to you is not that the token expires, is that when you restart the server, you create new keys automatically, because that's the logic you implemented. Normally in a real world application, the keys will be externally set and you will only consume them from somewhere. That somewhere can be a path where you deploy them, it can be a vault where you deploy them, it can be a database where you take them from. So remember, in my example here, I simplify the things, and I'm always at the start of the application generating new key pairs. Actually, I only generate one key pair. I made the simplest implementation possible. I only have a source with only one key pair generated at the start of the application. So the reason your access token doesn't work is because when you restart, it's not because it's expired. It's not expired. You can check that in JWT.io. It's not expired. The problem is that automatically when you restart the authorization server, if you implement it this way, it will have different keys. What you should do, like you would do in a normal application, is implement this bin to take the keys from somewhere where you have statically set them and you can rotate them statically, and not generate them at the application startup, and that will solve your issue. So I hope that's clear and will save you. And then okay, you could save it in a database with something like the timestamp. I'm not sure what we discuss. I hope you don't discuss about the access token, because the access token, if you store it in the database, you implement something like it's something different. It's called blackboarding, and I don't recommend you that, especially if JWT tokens, you don't have to store them in the database. Why doesn't the Opaque mode generate a refresh token? Very interesting question. Do I have the refresh token here set up and it didn't generate one? Where is my client actually? So the answer to your question, it doesn't generate a refresh token because I never actually set the refresh token grant type. If I would have set the refresh token grant type, you would have had a refresh token as well. So it does what it must. The authorization server, the way I configured it, it doesn't ask for a refresh token. Remember, for a refresh token, you specifically need to add the grant type, the refresh token grant type, which is not the case here. You can see I don't add it. So that's the answer to your question. When you authenticate through a phone login, a session ID is stored correctly. That's the default. This cookie can be used to issue more tokens. Can you remove? Yes, you can remove it after login using the normal Spring MVC API, I guess. So it's not related to Spring Security itself. Then it seems like OAuth2 resource server automatically imports Spring Security. That's possible. I haven't checked the dependency tree. If that's the case, then you don't need to add Spring Security anymore. Thank you for the tip. You can implement some config or socket web flags. That will be a different lesson. Okay, I will have a lesson specifically on reactive applications. For the moment, we care about OAuth2 resource server. Good, and hope that answers your questions. I'm now going back, and it seems IntelliJ didn't take this as a Maven project for some reason, so I have to manually edit. Okay, here it goes. And once it's synchronized, now we can add a very simple controller to prove our configurations. So yes, we need a resource to prove our configurations. So let's add a resource. And the configuration itself for the resource server. We define a bin of type security filter chain. We need to return HTTP build. And then we configure the authentication. If we want to create an OAuth2 resource server, we can create it like this. The Opaque token, you can set it either afterwards. Some of them prefer to put it like this. Other developers prefer to put it like this. So it is the same thing, the way you make the configuration, either as a parameter, a configured parameter, or afterwards. And two things you need to set. The introspection URI and the credentials, of course, because as you have seen in Postman earlier, the way I used it, I had to use basic authentication, so you need to provide the credentials. If you don't provide the credentials, then of course you know what that means. You will get 403 forbidden when the introspection endpoint is called, and then the resource server will not be able to validate tokens, so it won't work. So introspection URI, and I'm going to make sure I'm taking it with copy paste from the authorization server configuration itself. Again, remember, I'm usually in demonstrations setting them hard-coded, but you should never put them hard-coded. Any kind of information that is different depending on environments, they should be in the properties file. The only reason I don't do that is because I save time this way and I allow you focus on what's essential in our discussion. And then you know that the credentials are client and secret, and yes, you know that the credentials, especially credentials, should never be hard-coded. They should not even be in the application properties files. The application properties files should inject them from some kind of vault or environment that keeps them safe. And that's the authentication part. And of course, besides the authentication part, you need to have also the authorization rules. Otherwise, by default, everything will be permitted and we can't prove that our implementation works. So authentication, authorization, build the bin and put it in the Spring context, and that's basically it. So that's basically it. And we can prove it's working. Hopefully I didn't forget anything, and that will work until this starts. Let me see whatever other questions you have. I have two questions. How does the resource server know a token has been revoked? Well, by default, it stores the revocation information in memory, but you can override that and you can implement whatever mechanism you want for the revocation. And secondly, the previous 14 lessons, are all of them about OAuth2? No, actually only the last 3 or 4 are about OAuth2. I've started discussing from the very beginning of Spring Security. I do recommend you view everything from the very beginning, and you can find them in a playlist on this same channel. They are all free, so that should be. And it didn't start, of course, because you cannot start two applications on the same port. So let's change the server port to 9090 or whatever other port is free on this computer. So we are able then to prove that it's working. I have 3 microservices that store some data and do some business login. Should each microservice be a resource server? No, usually when you have multiple microservices, you use a gateway, and then the gateway itself will be the resource server, and then behind the scenes that's the casual implementation. Behind the scenes, the microservices themselves, they are not any longer protected. However, there are different implementations. You can have protection at the application level at any of your microservices, and you can as well implement the protection using, for example, a service mesh. I'm going now into more difficult stuff, and I would not like to go into more details since it's not really related to our discussion. What is the device code grant type? The device code grant type is a grant type that implies you have a user, but you don't have an interface for that specific user. For example, imagine you would want to have authentication for something like the button you use to turn on the light or something like that. If you have such a device, whatever device that doesn't have an interface itself, but it needs authentication, then you use the device code grant type. The device code grant type, if I'm not wrong, it doesn't come out of the box in the authorization server because it's something quite exotic, but you can implement it by customizing the authorization server framework. So the authorization server framework helps you, gives you enough power to customize, adding other custom grant types such as the device grant type. So I hope that is clear. And yeah, that is now ready. And that is now HTTP localhost 9090 demo, I think it was. And then we need to make sure I add the proper header for authorization. Better followed by the token value. And that's it. So it works. So theoretically now if I uncheck this, press send, we should have 401. If I check it, so if I'm authenticating, then I have it right. And the last thing I want to show you is how does the authentication object look like. So with this regards, what we can do is add something like var a from security context holder get authentication, and I will put a breakpoint here, and I'm restarting the application, and we will be able to see that the response of the introspection endpoint has been changed, transformed in the authentication object that has been then stored in the security context. So let's see, calling it. it's sorry, it did stop actually in the breakpoint, which is fine. And then we can go here and we can see that, okay, the token value is the opaque token. And you can basically see what has been, okay, we have the principal bill. We have everything in the attributes, and that should be exactly what we have earlier seen. I think this was the tab. Okay, so the attributes of the response, of the introspection response. And then of course you will probably wonder, what if I customize the response? Well, if you do customize the response, then of course the framework offers you the possibility to translate it to whatever custom response you want. So remember that we have seen in the previous lesson also that we can do that with JWT. I taught you how to use a JWT authentication converter. But if you have an introspection, then you can basically define an opaque token authentication converter. And yeah, it's the same idea behind the scenes. You implement this object. So you have the contract, the interface defining the conversion, and you get the string. And you have to convert it into the authentication. So that's the same as we would have done with a JVT, but now you will have to call the introspection endpoint itself and get whatever information you need and enhance it the way you have defined it at the authorization server level. So yes, if you do change the way this response looks like, you can still take that information on the resource server side, but you will, like we did, implement a converter for JWT in the previous lesson. You will need to implement a converter here as well, but the converter will be for an opaque token this time. And that's it. So to be honest guys, I only have one more token, one more voucher, and I will share it with you now. So this is the last voucher I have for Spring Security, since you asked for it. But stay tuned on my channel, because I have I will come soon with some vouchers for other books as well. So yeah, that's it. With that being said, I think I have also covered what I wanted to show you today. So with this, we now know how to use non-opaque tokens. We know how to use opaque tokens. We have a clear understanding of using the authorization server and the resource server. So next time we will have to discuss about implementing clients in an OAuth2 system with Spring. And then probably in the next lessons after that, we will discuss CORS, CSRF, reactive applications, securing reactive applications, and of course unit and integration testings, where we will learn how to test our security implementations. So guys, with that being said, thank you very much for being here with me. I'm waving goodbye and hope to see you for next lesson next time. Have a great time for learning. Cheers everyone.